In this video, we are going to discuss about how to convert complex number in Cartesian form a+bi into polar form. Given z equal to 1 plus I. We will work out this question in 4 steps. Step 1. Represent in an Eigen diagram in order to identify the location of 1 plus I. We let the x-axis as a real axis denoted as A and the y-axis as the imaginary axis denoted as B. Now, by comparing z equal to a plus bi with z equal to 1 plus I, we clearly see that the real part A is equal to 1 and the imaginary part B is equal to 1. So, in this case, the point 1, 1 is located in the first quadrant. Step 2. Find the modulus of Z. Modulus of Z is equal to square root A squared plus B squared. So by substituting the values of A and B into the formula, so we have square root 1 squared plus 1 squared, and this is equal to square root 2. Step 3. Find the argument of Z. Argument of Z denoted as theta and is the angle measured from the positive x-axis towards the line. So here is the theta. So in this case, the angle rotates anti-clockwise. This means the angle theta is positive. So to find theta, it is equal to arctangent modulus B over A. So by substituting the values of A and B into the formula, so we get arctangent modulus 1 over 1. And this is equal to pi over 4 radian. And finally, step 4, we are going to write in polar form. So in polar form, z is equal to modulus of z times with cos theta plus I sin theta. So here we have modulus z is sec2 times with cos pi over 4 plus I sin pi over 4. Next question, given z equal to -3 minus 4i. Similar with previous question, we will work out this question in 4 steps. Step 1. Represent in an Eigen diagram in order to identify the location of -3 minus 4i. So we let the x-axis as a real axis A and the y-axis as the imaginary axis B. Now, by comparing z equal to a plus bi with z equal to -3 minus 4i, we clearly see that the real part A is -3 and the imaginary part B is -4. So in this case, the point -3, -4 is located in the third quadrant. Step 2. find the modulus of Z. So modulus of Z is equal to square root a squared plus b squared. By substituting the values of a and b into the formula, so we have square root negative 3 square plus negative 4 square, and this is equal to 5. Step 3. Find the argument of Z. Argument of Z is denoted as theta. And this is the angle measured from the positive axis toward the line. So here is the theta. In this case, the angle rotates clockwise. This means the angle is negative. And for this part, we denote it as alpha. So the theta is equal to negative, in the bracket, pi minus alpha. We put negative in front because the theta is negative. And for the alpha, we are going to find by using this formula, arctangent modulus b over a. So we have negative pi minus arctangent modulus. We know that modulus means always positive. So we have 4 over 3. By simplifying this, we get our theta is equal to negative 2.214 radian. So finally, step 4, we are going to write in polar form. So Z is equal to modulus of Z times with cos theta plus I sin theta. So we have modulus Z is 5 cos negative 2.214 plus I sin negative 2.214. Well, that's it. Thank you.